Consequence of failure and risk management. In this module, you shall learn about assessing consequence of failure, risk determination, assessment, and management. Consequence of failure about shortlisting those items and equipment with significant consequence if they fail. The consequence of failure analysis is based on the predicted failure mode. Should be documented, repeatable, and realistic. COF is about the consequence likely to happen in case of failure. COF considers three factors: health, safety, and cost. Because they all cost money eventually. RBI program is managed by the inspector, who manages the risk by addressing the probability of failure. So the inspection is more concerned about the probability of failure aspect, while the process safety personnel and management deal with consequence of failure aspect of risk management. So this can be a potential exam question. RBI the inspection is concerned about probability of failure, whereas process safety personnel and management with consequence of failure you are concerned. COF analysis would help comparing the relative risk of equipment within a plant. So remember, there is always a relative risk. It's not absolute risk. Loss of containment means release of fluid to the environment. The consequence could be safety and health issues, environmental pollution, loss of production and revenue, repair, replacement, and maintenance costs. RBI consider leak as failure, but other non-leaking failures such as functional and mechanical failures, leakage from a high-pressure side to a low-pressure side of the heat exchanger due to tube failure, relief valve failure, and rotating equipment impeller and seal failure could also be considered if specified by the owner and user. So remember, for example, if there is a heat exchanger, the tube failure, because the failure you can't see, the leak you can't see from outside, is inside. The tube is inside the heat exchanger. It's not considered a failure unless it's been included by the owner user. So leak always means external leak. Other functional failures are usually covered within reliability-centered maintenance programs. Type of consequence analysis. We shall address the qualitative or quantitative while determining COF. Please note that qualitative or quantitative analysis are two ends of a spectrum, and usually a blended version is used for determining the COF called semi-quantitative analysis. Now, qualitative consequence analysis, the consequence of failure, safety, health, environment, and financial impacts can be estimated on the basis of expert knowledge and experience and categorized into different classes. For example, A through E, A, B, C, D, E, or high, medium, or low. Quantitative consequence of analysis involves using a logic model, same as probability of failure when you use a quantitative analysis, depicting combination of events to represent the effects of failure on people, property, the business, and the environment. To calculate the COF, the following parameters are considered: type of process fluid, like molecular weight, density, flash point, boiling point, vapor point, flammability, toxicity, so how harmful or hazardous they could be. State of the process fluid inside the equipment and after release, whether it is in solid shape, liquid shape, or gaseous shape. Well, gas is very much active than liquid, and liquid is very much more active than solid. Operating pressure and temperature, leak size, how big the leak is, and the amount of inventory for release. Results of a quantitative analysis are usually numeric. So this can be a potential exam question. The results, is it numeric, or is it the estimate, or is it a model, or whatever it is? It's numeric. It's by numbers. facts and figures. Units of measures in consequence analysis. Depending on type of consequence of analysis, the consequence of failure analysis performed, the results can be expressed in different units, measures, and classes as long as consequence of failure results are comparable and can be used for risk prioritization and subsequent planning for inspection. Safety consequence could be expressed as a numerical value or based on the severity of the injury, fatality, serious injury, medical treatment, and first aid. Cost. Consequences may be expressed in relative monetary units or low, moderate, and high categories, and could be assigned to loss values of, say, $100,000, $1 million, or $10 million for a medium-sized company, and for a larger company, it's more, obviously. So, say they have shown a sample table here. If it's a category 1, it's a catastrophe, so it's over $100 million. If it's major, that means the cost is going to be between $100 to $10 million. And if it's serious, then it's $10 to $1 million. Significant is less than $1 million, but more than $100,000. Minor and insignificant is less than $10,000. So that can be explained in monetary terms. You can also assign cost to any losses, such as loss of production, loss of revenue, loss of quality, injuries, fatalities, fines, and land reclamation due to environmental pollution. Determining consequences in monetary units has the advantage of permitting the direct comparison of various categories of consequences on a common scale. So hence we put it in monetary terms. So we can compare different scenarios and how much it's probably going to cost. Affected area means the amount of surface area of the plant that is exposed to toxic dose and thermal radiation, explosion over pressure, and any other adverse effect as a result of leak. In order to rank consequences according to the affected area, it is typically assumed that equipment or personnel at risk are evenly distributed throughout the unit, or population densities assigned to the area. So we take the mean value of that. It might not be in actual scenario true. For example, at that point of accident, if there are not many people around, then obviously you have less consequences. And if there is more people happen to be, say, during working hours, and an accident happens, and obviously, you might have more fatalities or injuries. But just to streamline and consider the average value of what would happen. So, and that's why they are evenly distributed throughout the unit or population density. Consequence. Although this approach gives us a good comparison model between various scenarios, it does not provide the monetary or business impact. So affected area means the surface area of the plant. This could be a potential exam question. Environmental consequences is the least developed measures because the impact is not immediate but long term. This is like smoking cigarette, and people know that they say there is a chance of like 50% chance people die earlier because of smoking cigarette. Cut your life by, say, 10 years, but because it's not immediate, the effect, many people smoke. So if people know that they would, say, immediately die in a few months, obviously they wouldn't do that. So same thing is for environmental consequence. It's not immediately known, so it's long term. That's why it's the least developed measure. Environmental damage always leads to the use of cost in terms of dollars per year for the loss and restoration of environmental resources. Other considerations: safety, health, and environmental consequences categorized in table 4 and 5. It's good to read this. Table 4 shows 3 levels, while table 5 shows 6 levels. You can see here that the category is high, moderate, and low. And safety consequence means fatality, lost time injury, or first aid injury. So that's what they mean by category. And health consequence is long-term health issues, short-term health effect, but full recovery expected. minimal health, and then major offsite response, minor offsite, and minor on-site response. So first aid, you don't go to hospital. Normally just do a bit of band-aid or anything. So it's called first aid on the injury. Whereas the high and moderate, you probably end up going to the hospital. And then on a table 5, there is 6 levels: catastrophic, major, serious, significant, minor, insignificant. Other considerations as a result of leak include loss of reputation, increase in insurance fees, regulatory restrictions, and limiting production. So if there is a catastrophe or a failure and the loss of production, it's not only the shareholders, the share market may go down for that particular company, and you lose reputation, the reliability will be under question. There is also increasing insurance money. It's like making an accident, and so you are a high risk group according to insurance, and they increase the insurance, and then the regulatory restrictions will be more because they will be zooming on you, the government, if there is a failure or there is a catastrophe at the plant. Volume of fluid released, the severity of consequence mostly depends on the volume of fluid released, which in turn depends on failure modes: small leak, hole, rupture, amount of inventory, size of container, any detection and isolation device, shutdown valve. So if you have a shutdown valve, they would limit the amount of leak. If the amount of inventory is less, then obviously you will have less leak. And if you have a small hole, you have less leak. And if you have a rupture, it's much more. Consequence effect categories: the failure of pressure boundary and subsequent release of fluids may cause safety, health, environmental, facility, and business damage. Regardless of whether a more qualitative or quantitative analysis is used, some of the major safety and health factors to consider in evaluating the consequence of failures are as follows: flammable events, fire and explosion. Fire is the result of 3 factors: source of ignition, atmospheric air, and energy to ignite, and can cause damage in 2 ways: thermal radiation, heat, and blast overpressure or explosion. Heat would affect near range, while explosion would affect a larger range. So this is very straightforward, but this could be a potential examination. What heat would affect? Then the answer would be near range, whereas explosion would cover a larger range. The vapor cloud explosion, pool jet wash fire, and boiling liquid expanding vapor explosion are typical categories of fire and explosion events. The flammable event probability increases when vapor is present and ready to ignite and operating close to fluid flash points. Toxic release are only addressed when they affect personnel and public. Toxic releases can be spread far more than fire. Remember Union Carbide disaster in Bhopal, India, 1982, killing over 20,000 people. The toxic consequence depends on volume of fluid release and toxicity, speed of propagation of toxic gases, detection and emergency shutdown system, and population close to source of release. Includes release of other hazardous fluids, includes acid and caustic burn, steam burn. Non-toxic or non-flammable releases have much smaller consequence than flammable and toxic releases. Environmental consequence: the RBI program typically focuses on acute or immediate environmental risk rather than chronic long-term risk from lower level emissions. So this can be a potential exam question that they are on focuses on acute or immediate environmental risk, not long-term risk, because long-term risk is very difficult to establish and identify. So the companies, they are not bothered about that because they are unlikely that they will be punished for a long-term risk, unfortunately, and hence the RBI focuses on immediate environmental risk. The environmental consequence depends on volume of release, gas or liquid nature of release, any safeguard provided, like dikes or for storage tanks or emergency shutdown valve, close proximity to water resource, and the like. Liquid releases may result in contamination of soil, groundwater, and or open water. Gaseous releases are equally important but more difficult to assess, since the consequence typically relates to local regulatory constraint and the penalties for exceeding those constraints. It's like pollution control. Environmental cost is equal to cost of cleanup plus fines plus other costs. Production business interruption consequence. The main production consequence for RBI are financial. That includes value of the lost process fluid and business interruption for getting back to production. You can see there is a DOE fire and explosion index for estimating downtime after a fire or explosion. The consequence could reduce if there is a spare equipment available, or increase when it has a knock-on effect on the neighboring equipment, the other way around. There might be other indirect costs such as losing customer, losing market share, increase in insurance premium, and others. Maintenance, reconstruction impact. The cost to correct the failure and to fix or replace the equipment damage normally is measured again in monetary terms. Determination of consequence of failure. There are 6 steps for determining the consequence of failure. Please see the figure 8 on API 580. These steps are estimating the release rate, estimated total volume release, determine the type of release, slowly, continuously, instantaneous, dispersion, discharge in liquid or gas phase, estimate the impact considering any mitigating measure, and then estimate the consequences. Here you can see the flow chart that how it works, that to determine the fluid dispersion, toxic, and then assessing existing mitigation, and then coming to conclusion, what is the flammable events, other hazardous. And so this figure is good, just a good how to your line of thought that should go for estimating for determination of consequence of failure. Factors for estimating consequence. To estimate the consequence, consider physical properties, type of release and duration of release, wind and weather condition, dispersion of the released content, escalation effects, and mitigation actions, detector, emergency, shutdown, secondary containment such as dike for storage tank, and failure mode that affects rate of release. The type of fluid dictates type of release. For example, gases are dispersed, liquids are discharged, flammable gases and vapors may ignite, toxic release as health and safety issues for personnel. Factors for more rigorous methods. Please note that each risk is less than POF and COF. For example, if the probability of leak is 0.1 and the consequence of this leak catches fire is 0.01, then the risk is 0.1 multiplied by 0.01, 0.001. 3 general methods for estimating consequence are: classify consequence into categories: low, moderate, high, very high. Rank consequence, say a scale of 1 to 10. Or measure consequence, for example, determine the estimated number of fatalities for a scenario and the economic losses in monetary units.